Hello everybody. Now we will be studying about the simulation of a full adder. Full adder is a combinational circuit that performs the addition of three bits, that is two significant bit and previous carry bit. It consists of three inputs and two outputs. Two inputs are the bits to be added and the third bit is the input from the previous block. Full adder is usually a component in a cascade of adders with adds 8, 16 or etc. bit numbers. Coming to the block diagram, we see that it consists of three inputs A, B, C in and two outputs sum and carry out or C out. In the block below, it has inputs A, B, C, I, that is carry in from the previous block, and the outputs are S, that is sum, and CO, which is the carry out. And we see that to find the sum, A, B and Ci are XORed, and to find the carry out, AB, BCI and ACI are ANDed, and then they are ORed. This is the truth table, and in the truth table we see that when one of the input is high, sum is high. When both the inputs are high, the carry will be high, and when all the three inputs are high, both sum and carry will be high. This is the truth table using which we will draw the K-map to find the equation for the sum and carry. This is the carry out or CO expression. That is, in here we see that CO will be equal to B into Ci plus A into Ci plus A into B, and sum or S will be equal to A XOR B XOR Ci or carry in. Ci is nothing but the carry in from the previous block, and C out will be nothing but CO. Now simulating, we will create a new project. We will create a text file, new text file, write the program, save, adder.vhd. This is a VHDL program, so select this VHDL, save as type as VHDL, save, then go to add source, select the project, under that the file is add, give OK, then select this, then give synthesize. Initially in the program we have declared the library files, then the entity full adder is both A, B, Ci, which are the inputs of standard STD logic. S and C out or the carry out are the outputs of the type STD logic. In architecture, data flow of full adder is begin S will be equal to A XOR B XOR Ci, carry O will be equal to A and B or B and Ci or Ci and A. Now we will create a test bench waveform. Add TBW, next. This is a combinational circuit, so we will be selecting the combinatorial or internal clock. We will give the inputs. Initially all the three values are 0. Next A is high. Next make B is high. Next keep both A and B high. Then only C is high. Ci is high. Then A and Ci is high. Then is high, then all the three inputs are high. Save this waveform. Then come to the behavioral simulation. Select the test bench. Come to process window and give simulate behavioral model. We will see that when one of the input is high, only sum will be high, and when two inputs are high, the carry will be high, and when all the three inputs are high, both sum and the carry will be high. Carry out will be high. This is the simulated output. We see that when all the three inputs are low, sum and carry is low. When A is 1, sum is 1. When B is 1, again sum is 1. When A and B both are high, carry is high. And when C is high, sum is high. Again when A and C are high, carry is high. The last case, when all the three inputs are high, the sum and carry both are high. Only when two inputs are high, carry will be high. When one input is high, sum will be high. The same simulation can be viewed using the Verilog program. The Verilog program for full adder. Open a new project for this. Next, it has to be Verilog. Then next, finish. Open a new text file. Write the Verilog program. Save this as fulladderDF. It has to be a Verilog program. So save as type Verilog. Then add source. Select the project. It is FAV2 open. So that the file is FA. Okay. Select this and give synthesis. The program we have declared in the module inputs A, B, C, I, sum and CO as the outputs. And we have assigned S equal to A XOR B XOR Ci, and the carry out of CO is equal to A and B or B and C or C and A, C or Ci. Now create a test bench waveform. TBW. Again, it is a combinational circuit, so we will be selecting the combinatorial or the internal clock. Give the same inputs to the previous case. Finally, keep all the three inputs high. Select source for behavioral, select the test bench waveform And in the Xilinx simulator, select simulate behavioral model. And here also we see that when one of the input is high, the sum is high. When two inputs are high, carry will be high. And when all the three inputs are high, both sum and carry will be high. Initially, when the three inputs are low, sum and carry both are low. Next, when A is high and B and C are low, sum is high. Next, only when B is high, A and C is low, again sum is high. In this case, A and B both are high, so sum is 0, carry is high. Next case, the C is high, Ci, so sum and carry, sum is high, carry is low. This case, A and Ci is high, carry input is high, therefore sum is 0, carry out or carry is high. In the last case, when all the three inputs A, B, Ci or C is high, sum is high, carry out or CO is high. Thank you.